Okay, a quick look at the phenomenon of unequal crossing over and the effects that it can have, illustrated in the book with the little somewhat gruesome story of John Dalton's eyes. So, using the same general format here, on the top of the screen, you can see I have two X chromosomes, chromosome 1, chromosome 2, normal chromosomes identical. The green and red boxes represent two particular genes, one for the green responsive opsin, the other for the red responsive opsin, both of which are on the X chromosome. So if we get crossing over, say, here, and typically we illustrate that with an X, it doesn't mean something's wrong, it's just that it symbolizes this part of this chromosome crosses over and it gets attached to this part of this chromosome and vice versa. So they're simply swapping pieces. If we do that, then we end up with the X1 chromosome being attached to the remainder of the the X2 chromosome, and vice versa. The left end, as it's drawn here, of the X2 chromosome gets lined up with the right end of the X1 chromosome. And again, two different chromosomes in a female, so two different copies of the same chromosome, same gene, same order. Could be different alleles on the different chromosomes, but not in this particular case. It doesn't matter whether there are or not. So you can see that the end result here is two identical chromosomes that effectively are exactly as they were before, as far as these two genes are concerned. We can have a crossover event occur at some other position. Doesn't matter. We can have it happen here. And then, in that case, what we see is exactly the same thing, that we get the left end of chromosome 1 attached to the right end of chromosome 2, and the left end of chromosome 2 attached to the right end of chromosome 1. But again, these are both identical, effectively identical chromosomes. Now, what happens if these two homologs line up out of register, however? We can still have a crossover event, but it's, again, these two homologs are out of register. So what's going to happen now is that we're going to get the same thing as before, where the left end of the homolog number 1 lines up with, or rather is recombined with, and forms a chromosome with the right end of chromosome homolog 2, and the left end of homolog 2 lines up with the right end of homolog 1, resulting in two abnormal chromosomes. Now, in this particular individual, each of these cells is going to be okay because they've got 1-2 copies of the green and 1-2 copies of the red opsin. But in this female's gametes, you're going to get either a homolog with 2 copies of the green and 1 copy of the red opsin, and another homolog with only 1 copy of the red opsin, no copies of the green. If that X chromosome, which is missing the green opsin gene, and other genes as well perhaps, but we're concerned with the green opsin gene in this example, if that is fertilized by a sperm carrying a Y chromosome, then the male born from that fertilization is going to be colorblind for red-green because he won't have the green opsin gene producing the green opsin protein to distinguish green and red. So that's the bottom line of the problem caused by unequal crossing over, that depending on where the crossover is, which chromosomes it is, subsequent cells themselves, if it's a mutation in a somatic cell, the cells are fine, they just got a rearrangement of all the same normal genes. But if it's a gamete producing cell, a germline cell, then some of the gametes are going to have one bad, abnormal, defective, rearranged copy, and other gamete cells will have the other complementary rearranged copy, and this may result in problems further down the road.